Hey class, let's do the lesson 8 homework, which is the homework where you've got to come up with the equation of the sinusoid given its graph. Um, let's do it. So first thing I might do here is really look hard at my scale, because a lot of the mistakes that people are going to make is they're going to look at something like this, they're going to sort of glance at it and say the midline is right here, which is up by a box, so they're going to tell me the vertical shift is 1, and whoopsies, that's wrong, because our y scale, this is 2 right here, so this is 1, this must be a half. So our y scale is a half, which means our vertical shift is not 1, it's a half. So messing with the scale is something you better be ready for. So vertical shift's a half. This is 3 halves, not that it matters, but yeah. So looking here again, that means this here is -1. It's not always super obvious where the exact middle is. So just remember, if you want to find the middle, you can always take the top and bottom and average them. So you could do the 2 plus -1 divide by 2. I shouldn't write that there. Hold on. I'm going to regret that if I put that there. This is the vertical shift. So it's the average of the max and min. So 2 plus -1 over 2 equals 1 over 2 equals, equals a half. You're just averaging these things to find the middle. Now to find the amplitude, if it wasn't, obvious, then you would do max minus min over 2. These are pretty easy to confuse, right? Over here, what you're doing is the average. So it's max plus min over 2. That'll find you the vertical shift. Amplitude's different formula. You're going 2 minus -1 over 2. That's giving you 3 over 2. And that's our amplitude. Now again, you can see that anyway. If you can see that the midline is here and you're going up to here, then you can see you're going up 1, 2, 3 boxes, each box worth a half, so that's 3 halves. Excuse me. For the period, I would strongly suggest that you just kind of count the difference, count the distance from max to max or min to min. So I'm going to do that. Now, the other thing that's a smart pro tip is once you've identified those, think about this. If I were to shift this whole bad boy over by 3, then I can plop this guy on the y-axis. And if I shift this other guy over by 3, then I can see, instead of having to figure out what the heck I'm running between, what is this? It's the middle of 0 and a half, so it's a quarter. I don't feel like dealing with that. Just shift this thing over 3. Shift this thing over 3. Now you're running between 0 and 2. So guess what your period is? It's 2. Period's 2. That makes it easy. Of course, we don't have to do that. If you want to do it the hard way, then you can figure out this x-coordinate. It's -1/4. Not exactly like that was the hardest thing in the world. Figure this out. It's halfway between 1.5 and 2, so I guess it's 1.75. And then what you would do is just subtract those two values. So 1.75 or 1 3/4. Ugh, did I just write a mixed number? Ugh. Obviously, it's actually 7/4. We're going to just add to that -1/4. And there's your 6/4. Wait a minute. What have I done? Okay, I'm a dunce. Forgive me. We're subtracting those two things to get at the period. And then you get 8/4, which is 2. Because we're actually, of course, we're going minus this negative thing, which means I'm adding, which means I get the 8/4 for 2. See, all the more reason that you should just use this trick of, push this guy over onto the y-axis, and then however far you had to push this guy too in the same direction, and then read your answer off the axis. That'll typically be very easy. So anyway, with a period of 2, how do you find your b value? Pretty sure there's a formula for that. We said the b value is always going to just be 2 pi divided by our period. So 2 pi divided by 2 is a b value of pi, which is fine. We can have b as a pi. it means that all the pi values that we normally see on the x-axis as our x-coordinates, the pi's cancel out. So instead of counting, pi, 2 pi, 3 pi, the pi's are gone. And our x-axis is filled with real, rational values. All right, let's do this. So now we can write our equations. I want one of everything. I want a positive sign, a negative sign, blah, 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 blah. So they're all going to have amplitudes of 3/2. This is going to be sine. They're all going to have b values of pi. What they're not going to all have is the same phase shift, but they are all going to have the same vertical shift. So we've already got this whole shell established. We're going to use this same amplitude every single time, this same b value because they all have the same period, this same vertical shift. The only thing that's going to change is these thingamabobberinos phase shifts. So we're going to go 3/2 cosine. We're going to go pi something plus 1/2. All right, so red, orange, no yellow, so green, blue. Let's mark all of these starting points. All right, so if I'm a positive sine function, then I want to start on my midline. So I could start here. I could start here. Haha, just kidding. This is the decreasing part of the function. So that's where negative sign will start. But I could start here, or I could start here. But we did say in class that I would greatly appreciate it if you minimized your phase shift. So instead of phase shifting way the heck over to here, just phase shift over to here. Boop. And so that's going to be the starting point for our sine function. What is that? Well, it's right smack dab between 0 and 1/2, so it must be 1/4. And we went to the right, so it's going to be minus. So we know we'll fill this in as, I guess let's get all these x's in here in gray. And then we'll color code our phase shifts, but we're going to go to the right, so minus, and we're going by, we're going to 1/4, so 1/4. There you go. All right, I already told you, negative sign. I could phase shift way the heck over to here to be on the decreasing part of the function, but I feel like it's shorter to go over to here, so I'm going to do that. So what is that? Here's 1/4, 2/4, 3/4. So that's where I want to be. Now in orange, I went left, so I'm going to want plus 3/4. Okay, great. Cosine wants to start at a max, and again, you've got an option here, you've got an option here, there's an option over here too, but again, this is the closest, so we'll use that. That's putting me at 3/4, but to the right. So I'll fill in my phase shift as minus 3/4. And then lastly, an inverted cosine function wants to start at a min, so I could start here, but I'm going to want to start here because I want to stick close to the axis. So that's 1/4 again, and since it's left, it'll be plus 1/4. That's it. That is how you write the equations from the graphs. Okay. All right. I think that's pretty easy. Hopefully y'all do too. The only weird part is getting those phase shifts right, and I think you'll be fine with that. Everything else you read right off the grid, right? Amplitude, read it off the grid. Vertical shift, read it off the grid. Period, maybe that's tricky too sometimes, but I think it's fine. Let's do the next one. There's only 3 of these, so I'm happy to have this be a short video. So let's do this. Amplitude, I'm looking for that midline. Midline is certainly looking, if the max is 6 and the midline and the min is 4, I don't think it gets much easier than this. Midline's going to be here at 5. So from 5 up to 6 is obviously an amplitude of just 1, which means our A value is 1, so that's easy. To find our period, again, you want to just go from max to max or min to min. But since we've got a midline point right on the y-axis, we may want to use the midline instead. Just remember, don't go to here. That's only half a period. Obviously, that's fine if you remember to double it. But if I can see that half a period is pi over 2, then I know the whole period is pi. Is that exactly what the last one was? No, the period was 2. Okay, great. So the b value was pi. But yeah, if you're going to use midlines, then you kind of have to start at a midline, skip one, and go all the way here. We're starting on a decreasing midline point. We got to end on a decreasing midline point, not an increasing one. So whatever, I can see that my period goes from 0 to pi. Clearly it's pi. I'm going to get rid of them dots. And the pi, apparently. Also going to sneeze. I paused the video so you didn't have to hear me sneeze. Pretty courteous of me, I must say. Ooh, that's thick, and that's fine. Alright, so again, the b value is 2 pi divided by the period, so it's 2. Our vertical shift is our midline, so it's 5. And then, you know, the rest from here should be cake. Let's go red. Our positive sine function, well, this happens to be the one that's equidistant. So I don't think we've seen this happen in class, but I don't care. You're going to be able to write a rule where you're going to either add pi over 2 and you'll be phase shifting left onto this point, or you'll go minus pi over 2. You'll be phase shifting right onto this point. But both of those points are correct starting points for positive sine. And since they're equidistant from the y-axis, you can just take your pick and use either one. It doesn't matter. For negative sine, we're going to have no phase shift. We're going to just start right on the y-axis and have no phase shift, which is great. For positive cosine, we want to be at a max. This is, of course, the closest. And for negative sine, negative cosine, we want to be at a min. So there's everything. Those are going to be the points I want to choose. And then we just write the rules. Let's do that in lavender. Because as you all know, Lavender Brown is my favorite character from the Harry Potter series. So we're going to write our equations in lavender. So if my amplitude's 1, then I don't have to write it. I'll just write sine. If my b value is 2, I'll write it. If I'm positive sine, then we said we're going pi over 2, and it doesn't even matter which direction. So we're just going to go x. I guess I'll go minus. So I'm phase shifting to the right. But it literally doesn't matter. Our vertical shift is up 5, so up 5. Great. Next, we're going to go negative. Oh, geez. Yeah, that's fine. We're going to go negative sine. 2x. Since there's no phase shift for this guy, you're not going to open another set of parentheses or nothing like that. You'll just go ahead and simplify that. And then it's plus 5. Let's go just cosine. 2x. Positive cosine's this guy at the max. This must be pi over 4. And since it's left, it must be plus pi over 4. Plus 5. And lastly, we got negative cosine, 2x. Same phase shift, same pi over 4, but it's to the right, so it'll be minus. That's it. That's all of them. Number 3. Whoa. All right. We got a max of 5 and a min down here at negative 9. So we've got a formula for amplitude if you don't feel like, calculating all this, but you'll subtract. 5 minus negative 9 is 14. 14 divided by 2 says the amplitude is 7. For the vertical shift, we said we could find the midline by averaging these two numbers. So 5 plus negative 9 is negative 4. Chopped in half tells me that right here, negative 2 is my middle. And that certainly looks right when you look at it. So the vertical shift's negative 2. From here you can also double check everything. Negative 2 adding 7 gives 5? Yeah. Negative 2 subtracting 7 gives negative 9? Yeah. So you know that negative 2 is the middle, and you know that your amplitude's right. You can just double check. Our period. We're trying to get a little tricky here, I guess. I suppose you've got a min and a min here that you can just pair off. But I don't know. Let's pretend for a hot second, because I would do this to you on a quiz. Let's pretend for a hot second that I gave you this much. Let's say the graph actually ended here. Then you don't have two of the same points that you can pair off. I suppose you could pair off midline to midline and then double that, right? But don't be so wedded to this idea of having to do min to min. You might not have a second min. Don't be so married to this idea of max to max. You might not have another max. And God help me, I suppose, if I really wanted to, I could give you so little of the graph. I don't know. How would I do this? I could block off this side too, I guess. Go just a little bit here. Now you can't even go midline to midline. Let's just play that game. Guess what? You still have the option, of course, of just going min to max and doubling that, right? There's many ways to get at the period of our function. So let's pretend we're doing this. A half to 2.5, I think that's a change of 2, so doubling that period's 4. This shouldn't be hard, really, but I'm sure there's a way I could make it more challenging. Anyway, there you go. Period's 4, we should all agree. That makes a b value of 2 pi divided by 4, so pi over 2. Alright, again, let's just find our starting points so we can do our phase shifts and then we'll be done. So if I'm color coding again, we're gonna go red. Are you red? No, you're not. Terrible. Red, orange, no yellow, so green, blue. Okay, great. So positive sign wants to start on a midline point that we're going up from, so right there fits the bill. Negative sign wants to be on the midline but decreasing. Cosine wants to be at a max. That's the only max we got. Negative cosine wants to be at a minimum. There you go. Alright, great. So we did it. I guess we're going to go 7 times the sine of pi over 2 x, some phase shift, minus 2 on the end. The phase shift is 1.5 to the right, so it's minus, and nobody says 1.5. Come on, guys, seriously, just use fractions. I'm serious. Use fractions. Alright, next one. Negative 7 times the sine of pi over 2 x, some phase shift, minus 2. Our phase shift to this midline is a half to the left, so plus 1/2. Positive 7 times the cosine of pi over 2 x, some phase shift, minus 2. That phase shift is in green. It's 2.5. Give it to me as 5/2, or I'll be super sad. Okay. Negative 7 cosine pi over 2. Ugh, boring. X, some phase shift, minus 2. I wonder what that phase shift is. I guess it's a half, and it's minus. Okay, great. I did a good job. That's everything. So that's how you write these functions. I think we're good. That's the last video for me because I did the last one first. So you guys should now be able to find the lesson 9. Yeah, I posted 9 first, I posted 7, and now this is 8 about to get posted too. Didn't screw anything up, did I? Nah. Okay, cool. If you see any mistakes, let me know. It would be lovely if you guys left comments, just like a hey, thanks, this was nice of you. Giving a thumbs up is fine too. Just something that acknowledges that you actually, appreciated it. Alright, have a good one. Get some sleep. See you in the morning. Bye.